So today, I'm going to explain summation.
Now, summation, quite simply, is the way you add up a series of numbers. Now, before I get on to explaining what summation itself is, I should probably explain a series. Now, a series is just a set of numbers that follow a pattern. For example, the series 2, 5, 8, 11, that is a series. It follows a pattern. Now, if it does not follow a pattern, it is just a random group of numbers, it is a sequence. For example, 1, 7, 8, 223. That is not a series, that is a sequence. Because it does not follow any set pattern, the numbers are just random. For a set of numbers to be a series, it has to follow a pattern. And for every series, there's an equation that models it. Because it follows a pattern, there can be an equation that models it. For this series can be modeled by the equation 3x minus 1. And the way the equation works is the number you plug in for x is the position of whatever number in the series you get. Like, for example, say I want the first term in the series, then I plug in 1 for x. I, do the math, and I get 2, which means 2 is the first term in this series. If I want the second term, I plug in a 2 for x. If I want the third term, I plug in a 3 for x. And so forth and so on. Now we can get to summation itself. Now, to indicate that you want to sum a series of numbers, you have to write the Greek letter sigma, which sort of looks like an E. That is essentially the Greek letter sigma. That indicates that you want to sum a series of numbers. Next, you need to indicate, alright, what term do you want to start with? And you do this by, beneath sigma, you write I equals, and then the term you want to start with. In our case, we are always going to start with the first term. While you could theoretically start with the second or third or some other number term, for our case, we are always going to start with the first term, because when I show you the summation formulas, you're going to need to start with the first term in order to get those to work. So get used to just starting with the first term, and adjust your series as such so that you start with the first term when summing them. Next, you indicate, alright, how many terms are we summing? Which you then put the number of terms you're summing on top with the n, which also is the last number term of the series. For example, say we have 5 people in a room. We have a first, a second, a third, a fourth, and a fifth person. The fifth person, or the last number person in the room, is also the same as the total number of people in the room. It's how that sort of kind of series number thing works out. So, the n up here is the last number, or the last number term in a series, which is also the number of terms in that series. So that is just how it works out, as a side note. But nonetheless, you write the last number term of the series that you want to sum for your summation as for the n at the top of the sigma. Next, you write the equation for your series. Like, for example, in my previous series example, 2, 5, 8, 11, which was represented by 3x minus 1, you would put the 3x minus 1 in there for the f of x. So this is where the equation for the series goes. And that indicates that you want to sum the first to the nth term of some series, represented by that equation. Now, I'm going to give an example of this summation process, and for the example, I'm going to use the first series I showed, the 2, 5, 8, 11. Now, for that, you want to start with the first term, and you want to go to the fourth term of the series, and you are using this series equation, 3x minus 1, to indicate, alright, that is the series I want to use. So that means that you take your first term, plus your second term, plus your third term, plus your fourth term. And you add those all up, and you get 26. So that is what that indicates. That indicates that you want to, that this here indicates you want to add up all these terms, and you will get that. So that is how the summation process works. Now, while summing the numbers by hand may not be a big deal when you only have a small series, when you have a large series with potentially several hundred numbers, you're going to want to find an alternative as to how to sum up that series. Luckily, there are alternatives, which are the aforementioned summation formulas. And there are several of them, 3 of which I'm going to show in depth. Now, the first summation formula is if, for our sum, we are just summing a series of numbers that are all the same number. Like, for example, say we're summing the first to the third term of 7. The equation is 7, so we're just summing all the same number. That C indicates constant, indicating that it is just a single whole number. So we are essentially summing up that series, which you may notice is the same as multiplying. Because, you know, multiplying is taking the number times however many of it there are. I mean, we are essentially using the definition of multiplying to figure it out. We have 3 7s, so we're taking 7 times 3. I mean, if you know how what multiplication is and you know how it works, I shouldn't need to explain this much further. But nevertheless, that equals 21. So that is our first summation formula, which is our constant, if we have a constant, times the number of terms in there, or our n, which, as you remember, n is the number of terms as well as the last term. I covered that earlier. Now, our next summation formula is if we have a variable. In our case, we're going to just have it be as I. So that means that if instead of a constant, we have a variable there. For example, like our equation for the series could be y equals x. That could be the equation for the series. That's an example. Now, the summation formula for this is n times n plus 1 over 2. Now, to get an example, we're going to say that this is our equation, and we're going to sum up the first to fourth term of it. So, if we were just to do it the long way, that would be 1 plus 2 plus 3 plus 4. And add those all up, we get 10. While, if we were to use our summation formula, we take 4 times 4 plus 1 all over 2. We can cancel these, we get 2. This is 5, so just 2 times 5, which is 10. So this is the summation. So if you have a variable alone, no coefficients or anything added to it, the variable has to be alone, you would use this summation formula. Then, if we have our variable squared, we would use this one. The summation formula for that is n times n plus 1 times 2n plus 1 all over 6. Now, for an example for this, to show you that this works, I'm going to use the equation y equals x squared. And then I'm going to do it from the first to third term. So we have 1 plus 4 plus 9, which is 14. Now, if we were to use our summation formula, we would have, we're doing the first to the third term, so we'd have 3 times 3 plus 1, which I'm going to go ahead and get the adding out of the way right now. 3 plus 1 is 4, times 2 times 3 plus 1, and 2 times 3 is 6, plus 1 is 7, so I'm going to go ahead and get that out of the way as well. Just save ourselves some room, because as you can see, we're running out a little bit. This 3 and 6 cancel to give us a 1 on top and a 2 on bottom. And then that resulting 2 cancels with the 4 to give us just the 2 on top and the 1 on bottom, which is 1 times 2 times 7, and 1, which is just 14. So as you can see, that summation formula works as well. Now, there is a third summation, or actually really a fourth summation formula I'll show you, which is if you have I cubed. And what that would be is you would just take the I equation and square it. Now, there are more than these. There is one if you have I to the fourth, or I to the fifth, or I to the sixth, or so on for an infinite number of powers. However, I can't think of a situation as to where you would need more than I to the third. In fact, that's probably a bit excessive. But if you needed more of them, you can look them up online. Now, you may have noticed an issue with the summation formulas in that for them to work, the constant or variable needs to be alone. Nothing, no coefficient, and nothing added to it. For these, you cannot use the summation formulas. Luckily, however, there are ways around it. There are certain manipulations you can do to summation formulas. Now, for this one, you can bring the constant out front. If you have a coefficient, you can bring the coefficient out front. So, instead of this, I could have it be 2 times the sum of I equals 1 of x from the first to the third term. Now, I'm going to give an example of this. So, say we sum up the terms a long way. This would be, let's see, the first term would be 2, plus then 4, plus 6. Add those up, we get 12. So the long way, we get 12. So, by doing it this way, we should get 12. Well, this is 2 times then using our summation formula, because we have the variable alone now, of 3 times 3 plus 1 over 2. Well, these 2's cancel. That's the 3 plus 1 is 4, which just leaves us with 3 times 4, which is 12. So as you can see, one of our operations we can do with summation formulas is bringing a coefficient out front. Now, however, let's say that we have, we're adding 2 terms, like we're adding x plus 1. Well, we don't have a summation formula for x plus 1. Luckily, we can split apart addition, as well as subtraction. Like, for example, we have 4, and then what we can do is we just have that, and then we can have it for x, and then we plus the summation of from 1 to 4 of 1. So we can do that. Now, if we're to do it the long way, let's see, we get 2 plus 3 plus 4 plus 5. Add those all up. Let's see, we get 14. So the long way, we get 14, which means that by doing this, we should get 14 as well. Well, if we use our summation formulas again, so we got 4 times 4 plus 1 over 2. See, so then that cancels, we get 2, and then that's still 5. So 2 times 5 is 10. And then we're adding that to, let's see, that's 1, so that's 1 times 4, using our constant summation formula. So that gives us 4, and 10 plus 4 is 14. So as you can see, we have ways around the issues of variables not being alone. If we have a coefficient in front of it, we can bring the coefficient out front, in front of the summation formula, to thus get the variable alone. Or, if we're adding terms for our summation, we can split those additions into 2 separate summations. So we then have summation formulas for each of them. So we have those 2 options available to us if the variables are not alone. Now I'm going to give an example as to how you would use the summation formula to, tie everything together and just show you how you might go through it. And for the example, I'm going to use this series that I've been using throughout the video of 2, 5, 8, and 11. Which is represented, because we're going from the first, indicated by I equals 1, to the fourth, indicated by that 4 on top, of the series of 3x minus 1. Now, before we get into the actual summation formula method of it, I'm going to just add up the terms separately to see what we should get. So we take 2 plus 5 plus 8 plus 11. That will give us 26. Now, the summation formula way. So from here, the first step we need to do is we need to split apart the 3x and the 1 using that summation formula property we learned earlier. And then next we need to take the coefficient out front from the 3x, so we just have 3 times the sum from 1 to 4 of x minus the sum from 1 to 4 of 1. And now we can get into our actual summation formula. So we have 3 times 4 plus 1 all over 2, and then that's minus 4 times 1. Let's see, that 2 and that 4 cancel, this give us 2, so 2 times 3, that's 6, and then 4 plus 1 is 5, and then that's minus 4 times 1, that's just 4, 6 times 5 is 30, minus 4, and 30 minus 4 is 26. So, as you can see, this summation formula method does in fact work, and it will work for any series like that, where you have an equation, and then you can just use summation formulas. So it works for any situation like this. And now you know how to do it.
But yeah, hope you enjoyed it, hope you learned something, and see ya.